Hello students, welcome to our TEJAS series. So those were the questions from calculus. See the first question, see both the questions I think are a very good one, and if you have got the answer, see I will again request you all, those who are regularly solving these questions must comment it in the comment box when you get the post, so that we should know that who are getting the correct answers. Okay, and I will definitely appreciate those efforts also. Let's start for the first question. First question is a question of limit, which says limit as x approaches 0 of under root of 1 plus x squared into tan of sine inverse of tan inverse x plus 2 times under root of 1 minus x squared into sine of tan of sine inverse x minus 3x whole divided by x raised power p, and if this limit is a non-zero finite value, then we have to find p here. Okay, see the first step is to simplify this trigonometric and inverse trigonometric functions here. Okay, so what can we write for tan inverse of x? So if we wish to convert it to sine inverse, what will we get here? Okay, so how do we do it? So if I go with like a kids method, I call it kids method. Okay, how? So I say, okay, let tan inverse x be p. So that means tan p is x. So I will call this angle to be p, and tan p is opposite side upon base. So I am considering it to be x and 1. Hence the hypotenuse is 1 plus under root of 1 plus x square. So therefore what will be sine p? Sine p will be opposite side upon hypotenuse, bachcho. So for tan inverse x, so see now, okay, of course, so p will be taking sine inverse both the side, you get sine inverse of x over under root of 1 plus x square. Okay, and p was tan inverse x. So what does that mean? That means that we can replace tan inverse x by sine inverse of x by under root of 1 plus x square. Similarly here, it is sine inverse of x. So I will write sine p as x. Here the hypotenuse is 1 and opposite side will be x. So the base will be under root of 1 minus x square. So now let's do it. So limit as x approaches 0 under root of 1 plus x square into tan of sine inverse of x by under root of 1 plus x square. That's the first term. Okay, then we have plus 2 times, so we have plus 2 times under root of 1 minus x square into then sine of tan of sine inverse of x. So I will write it as sine of tan inverse of, okay, it was sine inverse of x, so opposite side will be x, but hypotenuse, so it will be x upon under root of 1 minus x square, and then minus 3x whole divided by x raised to the power p. Okay, so next step is limit as x approaches 0. We know from the definition of inverse trigonometric function, we know that f inverse of x can be replaced with x. Okay, within domain range condition, but we can replace it with x. So it is under root of 1 plus x square. This and this will go away. So it's tan of x over under root of 1 plus x square, that's 1, plus 2 times under root of 1 minus x square. Tan inverse is gone, so it's sine of x over under root of 1 minus x square, that's another, minus 3x over x raised to the power p. Now I will suggest you people to use series expansion. So use series for tan and sine. So let's write the series of tan. To tan of t is t plus t cube by 3 plus 2 times t raised power 5 by 15 and so on till infinity. Okay, similarly we can write for sine. So sine of t, it's t minus t cube by 3 factorial plus t raised to power 5 by 5 factorial minus so on till infinity. So instead of t in tan, we have x upon under root of 1 plus x square, and in sine, we have x upon under root of 1 minus x square. So let's do it. So therefore, limit as x approaches 0. So it is under root of 1 plus x square, opening the series. T is x upon under root of 1 plus x square plus its cube, x cube upon 1 plus x square raised to the power 3 by 2 into 1 by 3 plus x raised to the power 5 upon 1 plus x square raised to the power 5 by 2 into 2 by 15 plus dot dot dot, and then plus 2 times under root of 1 minus x square, expanding the series for sine t. So it's t again, x upon under root of 1 minus x square minus x cube upon 1 minus x square raised to the power 3 by 2 into 1 by 6 plus x raised to the power 5 upon 1 minus x square raised to the power 5 by 2 into 1 by 5 factorial minus dot 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 minus 3x whole divided by x raised to the power p. Okay, now is the time to simplify. Okay, so I can take under root of 1 plus x square common from this entire term, so it will be left with this. Here you will be left with square and so on. It's gone. Similarly, you will take 1 upon under root of 1 minus x square common from the second bracket. It will get cancelled here. You will be left with 1. You will be left with power 2 here, and that's it. Okay, now this is x plus 2x minus 3x. So these terms are gone. Fine. Now take it inside. So this is x cube upon 3 times 1 plus x square, and this is minus 2 that gets cancelled. So let's simplify it. So it is x cube upon 3 times 1 plus x square. This is minus x cube upon 1 minus x square into 3 plus some x raised to the power 5 and something and something and something upon x raised to the power p. Let's simplify it. Okay, let's try to simplify it. So we get x cube by 3 as common. So 1 minus x square minus, okay, see what do we get here? Limit x tends to 0. I take x cube upon 3 and then you take LCM, this thing. What do we get in numerator? Okay, we get 1 minus x square minus 1 minus x square here, then x raised to the power 5 times something, and then whole divided by x raised to the power p. See, what I want to say here is that, see, 1 and 1 gets cancelled. So the minimum degree term in the numerator is x raised to the power 5. So limit as x approaches 0. And one more thing, bachcho, as x approaches 0, denominator has no role. Denominator of numerator. When you take LCM here, so what? Look at the denominator terms of the numerator. Okay, this one, this one, this one. None of them is contributing to 0 by 0 form, because as x approaches 0, these all terms in the denominator approaches 1. So they have no role to play. Okay. Now what happens is you have x raised to the power 5 times something plus x raised to the power 7 times something dot 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 upon x raised to the power p. Now be very clear about it. I think we have already discussed it, that if you have 0 by 0 indeterminate form and both numerator and denominator are algebraic terms, then to have non-zero finite value. See, that's what has been specified here. To have non-zero finite value, what we need to have? We need to ensure that the least degree of numerator and denominator must match. So for that case, p should be 5 here, okay, because the least degree of the numerator is x raised to the power 5, so the least degree is 5 here, bachcho. Okay, so that's it in this question, bachcho.